Is it possible to port Spelunky to the Godot game engine, adding new features like modding support while keeping things as accurate as possible? This idea hit me a while back, and being a fan of both Spelunky and Godot, I knew it was something that I wanted to work on. Now, you might be more familiar with Spelunky HD or Spelunky 2, but the game I focused on porting was the very original Spelunky Classic, a pixel art GameMaker game released in 2008 that served as a template for the later Spelunky remake. With HD being a more refined version of the original, Classic doesn't get as much attention, but it has its own unique feel and details that make it distinct enough to be worth playing, and it holds an important part in history. However, it's a bit harder to go back to compared to the HD version, given that it runs at 30 FPS and doesn't have modern features that you might expect from today's games. So I had the idea. What if I ported the game to the Godot game engine and gave it modern features like higher FPS, widescreen, controller rumble, and modding support, maintaining as much accuracy as possible but adding quality of life improvements to make it a smoother experience? The good thing is that the source code is available, which means there's no reverse engineering to do. My first experiment was to get the level generation working, just to make sure that my idea of a port would be viable at all. In Spelunky, levels are divided into rooms, and each room runs a script called roomgen, which generates a unique string. This script picks from a set of patterns and then alters it in a random way, making each room feel unique. The string it outputs might look meaningless on its own, but each character actually corresponds to a different object. When we lay it out on a 10x8 grid, we can actually see how the room takes its final shape. By completing this for all 16 rooms, we have our final level layout. After this, there are other scripts to add more enemies and items, but this is how a basic level is created. If you want to learn more, I'll leave a great resource in the description. When implementing this in Godot, I copied and pasted the code, written in GameMaker language, and translated the code by hand to get it running. It's actually not too dissimilar to GDScript, which made things pretty easy, but just time-consuming. For the GameMaker engine functions, I created a separate class called GML and recreated these functions by basically guessing how they work. So, I tried to run the project and it looks like things actually worked. Once I saw the levels appearing on screen, I knew that this approach could be viable for the whole game, so I started looking more into the original project structure. My goal at this point was to figure out how to map GameMaker concepts to Godot. To do that, I had to learn more about the engine and how it works. By looking through the folders and documents of the source code, as well as the documentation for the engine, I was able to piece together how things work. In GameMaker, each level in the game is called a room, and each room is made up of objects, which corresponds to things like the player, enemies, items, blocks, and other parts of the level. On top of this, each object contains events that run at different points, such as a create event that runs when the object first spawns in, or a step event that runs every frame. Thankfully, GameMaker makes it pretty easy to see all this information, with everything needed being neatly organized inside folders and XML files. When trying to set things up in Godot, we can start to visualize how things can be recontextualized. Rooms become scenes, and objects become nodes within the scenes. Events can be grouped together as part of the node script. To set up the objects, I created a tool script that translates information about each object into something that Godot can understand. By clicking a button, I can generate sprites for the object and set other values based on the XML files I mentioned. For example, depth corresponds to z-index in Godot, although the sign needs to be flipped. To set up the levels, I created a room scene that generates all of the objects needed for each level when it runs. This is based on the XML file each room has in the original game, which lists all the objects and their positions. But right now, the objects don't have any events implemented, so they don't actually do anything. For now, let's focus on the intro room and only add events for objects in that room. To get things actually running, we can set up a main loop inside the physics process function and then change our physics frame rate to 30. This means this loop will run 30 times per second, the same as the original game. Then, we structure the loop to run in the same order as the original engine. Fortunately, there actually is a page in the GameMaker documentation that goes over the order in which things run, so I was able to use that as a reference. Now, with the loop set up, let's start the intro scene and see how things are running. And it looks like everything is working as planned. After this, the first object that I worked on completing was the player. I figured being able to run and jump around, even just on the title screen, would be a good starting point. The player is also one of the most complicated parts of the project, coming in at over 5,000 lines of code after conversion to GDScript. One thing I should note is that the original code isn't actually split into inner functions. Each event is its own file, but inside an event, it's all just one script that isn't split up into functions at all. So the first thing I did was organize the player script into separate functions to make debugging much easier. After lots of work here, I had the player up and running with surprisingly few issues, and I was happy to get one of the bigger parts of the game finished. Once I had the player working, I moved on to the rest of the objects, of which there are 450 in total. To do this, I ran a Python script on the event files that converted the original code as best as possible to GDScript, and then added this new code as a script for each object. Then, I went through and cleaned it up by hand until there were no errors. The thing is, the objects themselves are so interdependent on one another that I couldn't really test the game in chunks. I basically had to implement every object one at a time, and then test the full game once they were finished. I spent a while going through each object and cleaning up the code my Python script generated. To make it feel like I made some easy progress, I started off with the smaller objects first, some of which had no code at all or only a few lines. By the end, they were getting bigger and bigger in scope, but eventually I finished them. After that, with the rooms and objects being complete, the content of the game itself was fully implemented, but I still wasn't even close to having the game where it needed to be. I still had lots of bugs and inaccuracies. At this point, I began to realize that this project was more of an engine recreation than a port of just Spelunky. That GML file I mentioned earlier, it ballooned in size as I added more and more GameMaker methods. As an example, I actually skipped over talking about one of the systems I had already implemented. In the footage of the player I showed before, you can see that collision is already working here, but I'm actually not using Godot's built-in collision system. The original game's code is totally reliant on GameMaker's collision system, and nothing will work correctly without things running the same. Godot and GameMaker actually have pretty different collision systems, and it's not easy to swap one for the other. Godot compares bodies and areas against one another once per frame to see if they collide, and this is mostly handled for you in the background without having to worry much about it. On the other hand, in GameMaker, you can manually check a specific area, which can be at any arbitrary location on the screen. In Godot, there are some hacky ways to accomplish this, but the results can be finicky and the performance isn't great either. After lots of experiments, I eventually decided on just creating a custom system. The system uses a grid to store the position of each node. Then, each node gets a collision box to check against other boxes. Using the grid, nodes only have to check other nodes inside the same grid cell. This makes things pretty efficient, even with it all running in GDScript. So after the game was mostly working, there was a long refinement and bug fixing phase, where I chipped away at issues. Small things would often end up being fundamental problems with my engine reimplementation, so they would end up taking a lot of time. But eventually, things began to come together and I finally reached the point where I could build out new features. Adding support for higher frame rates was a high priority and one of the main motivators for the project. I tried using Godot's built-in physics interpolation, but with my custom camera and other custom systems, it didn't seem to mesh well, causing jitter and other issues, as well as a drop by half in FPS. I decided to make my own interpolation system to make things as smooth as possible. The way that this works is the game actually waits one frame to update the position of each sprite. Then, during the process function, which runs between these frames, the sprites are tweened to the next position. Once the next frame is drawn, the process repeats. There are some other things to account for, but that's the summary of how it works. This allows the game to look smooth at any frame rate, and none of the actual logic of the game needs to change in any way, since we're only updating how the drawing works. I also added ultra-wide support, which mostly came down to making sure that everything stayed centered when pulling the screen. I also added fake walls in areas that didn't have them before, like the title screen and the level transition screens. The credits and other areas still don't have anything on the sides though, so they look a bit janky at the moment. One of the last things I added before release was modding support. There's a great tool called the Godot mod loader, used by other Godot games like Brotato and Dome Keeper, which makes adding modding support for GDScript based games pretty easy to implement. I included some example mods at release, like a CRT filter and support for seeded runs. Just recently, I added custom character support and a daily challenge mode that lets you save a screenshot showing your progress when your run ends. The way that these mods work is they extend scripts from the base game. Then, when you declare a function with the same name as one in the original script, it will override the original. When you're finished, you export it as a zip file and it's ready to distribute. I had used Godot for a while before this port, but this was actually my first large-scale project in Godot, so I definitely learned a lot about the engine and about the porting process during this time. One thing I realized is that Godot actually has a lot of potential for ports of older games. If you don't want to convert everything to GDScript like I did, you could use GD extension to get the game running in a supported language, like C or C++. Then, by feeding an input file to the game and comparing the state every frame, you can verify that the behavior matches the original. Once the base game implementation is done, you can work on the rendering and audio systems. After that, you have the game running in an engine that has easy exports to many platforms, support for a wide range of controllers, rumble support, a flexible UI system you can draw on top of the game, shaders and particles, and everything else a modern engine has to offer. Basically, a lot of the more annoying parts of doing a port of a game are handled for you. I actually realized I could have handled Spelunky this way, using a GameMaker Classic recreation called OpenGMK, written in Rust. This would have probably been a lot easier, but the trade-off is GDScript based mods aren't really possible, or at least they'd be very limited. And for anyone trying to learn from the code, it would be more difficult than reading GDScript. So even though I took the long way with this port, it was a good learning experience and I'm happy with the final result. I released the project, called GD Spelunky, at the end of last year, so feel free to check it out on the itch page. The code itself is also available on GitHub. I included a project overview there that goes over the structure of the project in a bit more detail than this video, so feel free to check that out. I was working on this project for a while, so right now my main focus is on other projects at the moment. However, I'd still like to fix issues or make improvements when I have time. If you notice any bugs or issues, feel free to let me know. I also have some more ideas for videos in the future, and I'm planning to cover a variety of topics related to game development and Godot. Feel free to subscribe if you'd like to see similar content in the future. Thanks for watching, and peace.